Introduction to units of measurement and unit conversions. So the basic units of measurement in the clinical lab are based on the metric system. Length is measured in meters, volume in liters, or a cubic length unit like a cubic centimeter. Mass is in grams, and temperature is in Celsius. With the liters, volume, and mass, the length, volume, and mass units, there are prefixes and multipliers that apply. So if we have 1 milliliter, we're talking about 1,000th of a liter. If we have 1 kilogram, we're talking about 1,000 grams. So this chart will be useful that you can refer back to this chart. Units of length measured in, as I mentioned, the meter. So we have units listed here and their exponential equivalents that you can come back and review. So 1 kilometer is equal to 1,000 meters. 1 centimeter is equal to 0.01 meters. 100 centimeters is equal to 1 meter. 1 nanometer is equal to 10 to the negative ninth meter. 10 to the ninth nanometer is equal to 1 meter. These equivalencies are called conversion factors, which we'll get into when we talk about unit conversions. Volume is a derived unit. It's formed from other units. Many units of volume exist. It's a measure of space, and they're derived units. In general, length times width times height is how that's calculated. Any unit of length, when cubed raised to the third power, becomes a unit of volume. Cubic meters, cubic centimeters, and cubic millimeters are all units of volume. In the laboratory, it's important to note that 1 cubic centimeter, also called a cc, or you may see it written cm cubed, is considered equivalent to 1 milliliter. So here are various syringes, and you can see they are laid out by cc's. But here you can see the unit clearly says ml/cc. So milliliters and cc's are the same thing. In order to perform unit conversions, you need to know the conversion factor. Then you always start with the information they give you, with the number that you are given in the problem. Then you multiply it by its conversion factor, and it gives you the desired unit. These are some common conversion factors. This is kind of a handy chart that I put together for my chemistry students, but you can feel free to save it and use it. This is not all encompassing of everything that you would ever need, but it's a good starting point. So the American system, we use feet, inches, pints, quarts, gallons, tons, pounds. So in the American system, sometimes numbers are reported, and we have to then do the conversion to the metric system in order to put it into the patient's chart. So here we go with the first one. 26 feet is equal to how many inches? So you always want to start with the number that they give you, 26 feet. And when you're doing unit conversions, it is so important to put the units in the conversion. And then I like to do parentheses for my conversion factor. Because I put foot up here on the top, foot has to go down here on the bottom. We are dividing away the feet, because when we divide away the feet, we're left with the unit that we want to end up with. And the unit we want to end up with is inches. We'll put that unit up here. So 26 feet, again, our units have to be able to cross out. Now we're going to put in our conversion factor. So many of you know that there's 12 inches in 1 foot. If you don't, you can go back up to the conversion factor or look up the conversion factor. So now what we've laid out is a problem where we would multiply across the top and divide away the bottom. Now this one's super easy because the bottom's just 1. So anytime that we have 1s on the bottom, we can basically just ignore them. 26 times 12 divided by 1 keeps the same number. So 26 times 12, when we multiply across the top and divide away the bottom, we're basically dividing away the foot, leaving the inches as our final unit. So 26 times 12 equals 312 inches. Now, of course, you can always double check your work using the computer. There's conversion factors, charts everywhere. The AI can do this for you. But on the qualifying exam, if you're asked to do these unit conversions, you're going to have to be able to calculate them. So it's important that you know how to do this without just Googling the answer. So actually work out the problem. I've been doing dimensional analysis for I don't even know how many years now, and I still write out everything because writing things out ensures that you're not going to make simple mistakes. It also allows you to track your units. Now, these problems are going to get a lot bigger. And when we get into multi-step problems, having those units and having that practice working through the units up front is going to be really important. So, write out all of your work. Now I'd like you to pause the video, work through the next two, and again, you can use the conversion chart that I've provided. Okay, here we go. So 14 pints. We're going to start with the number that they give us. Because pints is on the top and we want it to cancel out, we're going to put it on the bottom. We're converting to inches. Quarts. Wow. I was looking at the problem at the top there. Quarts. Okay. So 14 pints to quarts. Now we have to get our conversion factor from pints to quarts. So we have the conversion factor here. 1 quart is equal to 2 pints. So 1 quart is equal to 2 pints. So the pints is going to cancel off. We do 14 times 1, which is still 14, and divide away the bottom. Divided by 2 gives us 7. 7 quarts. Now this next one here, 2.43 tons. 2.43 tons. We got tons on the top. We're going to put tons on the bottom. And we're converting to pounds. Now we have our conversion chart. 1 ton is equal to 2,000 pounds. So 1 ton, 2,000 pounds. Some common mistakes I've seen students make is they will accidentally put the wrong conversion next to the wrong unit. So you want to ensure that when you read left to right, it makes sense. 1 ton is equal to 2,000 pounds. So associate the correct number with the correct unit. Now tons is going to cross out. We have a 1 down here, so we can just ignore that. So we've got 2.43 times 2,000. And if we divide away the 1, it's still the same number. So 2.43 times 2,000 equals 4,860 pounds. So metric is going to be a lot easier because we're dealing in like numbers that have zeros in them. So we either add zeros or subtract zeros or move decimals. So these are a little bit easier to work with. So 2 liters to milliliters. 2 liters. Now because liters is on the top, we're going to put liters on the bottom. And we're going to convert to mils. So when we go to our conversion factor, we know that 1 liter is equal to 1,000 mils. So when we multiply across the top and divide away the bottom, we eliminate the liters and end up with the milliliters. So that becomes 2,000 milliliters. Go ahead and pause the video and work through the next two problems. Okay, so we have 420 grams. We're going to do our parentheses. Since grams is on the top, we got to put grams on the bottom. We're converting to kilograms. So kilograms is going to be the unit we end up with. When we go to our conversion chart, we know that 1 kilogram is equal to 1,000 grams. Now we multiply across the top, divide away the bottom, get rid of the grams. 420 divided by 1,000 becomes 0.420 kilograms. Again, the correct unit is so important. You want to make sure that the unit is correct and that you write down the units. So because we ended up with kilograms here, we're ending up with kilograms here. And this one, 80 meters. We're going to put meters on the bottom. We're converting to kilometers or kilometers. 1 kilometer is equal to 1,000 meters. We are going to multiply across the top, divide away the bottom, and we end up with 0.080 kilometers. Meters crosses off, we end up with kilometers. 80 divided by 1,000 is 80 thousandths. So let me just do this. 80 divided by 1,000. Yep, 0.080. Okay, so now we're going to convert between American and metric, metric to American. So 2.2 pounds is how many kilograms? 2.2 pounds goes on the bottom, kilograms on the top. Now we convert our chart. 1 kilogram is 2.2046 pounds. So multiply across, divide away the top, we end up with 1. This is our conversion factor is what was provided in the problem. So 1 kilogram. So cross out the pounds, we're ending with kilogram. Go ahead and pause the video and work through the next couple. All right, so here we go. 3.2 liters. We want to figure out how many gallons that is. So let's go back to our conversion. Liters to gallons. 1 gallon is 3.785 liters. 1 gallon, 3.785 liters. We are going to multiply across the top, divide away the bottom, get rid of the liters unit. We're going to end up with gallons. 3.2 divided by 3.785. We got 0.845 gallons. And 21.9 centimeters. Centimeters on the top, so it goes on the bottom. And we're converting to inches. The centimeters crosses off. 1 inch is 2.54 centimeters. 1 inch, 2.54 centimeters. So now we multiply across the top, divide away the bottom, and we end up with 21.9 divided by 2.54, 8.6 inches. Okay, solving multi-step problems. So sometimes there's not a direct conversion or an easy conversion when we are going to extremes, like extremely far apart units. So going from a kilometer down to an inch is going to be an extreme stretch. So we may have to do multiple steps in order to get to our final answer. So if we start with this one, we have 1.3 kilometers. And we want to get to inches. So let's look at our conversion chart. And we've got kilometers that can go to meters. And then we have, let's see, kilometers to meters. And then we can go meters to inches from there. So this is going to be a two-step problem where our first parentheses, we're just going to take it to meters. Then our second step, we're going to take it from meters to inches. So kilometers, kilometers, meters, meters, and then inches here. So when we type in the conversion factors, 1 kilometer is equal to 1,000 meters. And then we had 1 meter is equal to 39.37 inches. Now to solve these multi-step problems, you would multiply the entire top. Then, so if we want to make this equal, we would multiply across the entire top. 1.3 times 1,000 times 39.37. And we get 51181. And then you would divide away the entire multiplied bottom, which means you would take the 1 times the 1, which equals 1, and you just divide away the 1. Now, as I mentioned before, whenever you divide a number by 1, it's just the number that you started with. So you could ignore the ones, or you can write it out like this just to keep track of your parentheses. But your final answer for this problem is going to be 51,181 inches. And when you cross out your units here, you cross those out, and you end with this. So go ahead and pause the video and work through the next couple. All right, so we're starting with tons and we're going down to grams. So it would be good to do a multi-step here, 2.2 tons. And you can really choose whether you want to stay in the American side or switch over to the metric side right away. Let's look at what we have available. Tons. We have tons to pounds, or we have tons to kilograms. So I'm going to go for the tons to kilograms. So let's go ahead and make this happen. So tons is on the top. I'm going to put tons on the bottom. I'm going to put kilograms on the top. Now that I'm in kilograms, I'm on the metric side. I'm going to go all the way to grams. kg and grams. So now that I know what units are going where, I'm going to add in my conversion factor. So 1 kilogram, sorry, let me see, 1 ton is 907.2 kilograms. So 1 ton is 907.2 kilograms. Then we have 1 kilogram is 1,000 grams. So again, since we have the ones on the bottom, we could just ignore them. We can then cross out our units, make sure our units cross out. We're ending with the grams, and we're just going to multiply across the top. So we have 2.2 times 907.2 times 1,000. We end up with 1,995,840. Okay, last problem here, we've got 7.9 gallons, and they want milliliters. So I'm going to jump over to the metric system right away and go from gallons to the closest unit, which is going to be liters. And then from liters, we're going to go to milliliters. So, liters to gallons here. 1 gallon is 3.785 liters. And then we have 1 liter is 1,000 mils. Multiply across the top. We get 299.01.5. Temperature conversion. So you may encounter temperatures that you have to convert from one form to the other, and I like to use the equations that are in the upper right hand corner. So if you are given something in degrees Celsius, you would put that in for the degrees Celsius number as the variable and then solve for the F. If you're given the F, you'd put that in the equation for the F and then solve for the C. So going through the first one, 92 degrees Celsius, we're trying to convert to Fahrenheit. So since Fahrenheit is what we want to end up with, we're going to use the equation degrees Fahrenheit is equal to 1.8 times the degrees C plus 32. Now we're putting in 92 for the degrees C. So this becomes degrees Fahrenheit equals 1.8 times 92 plus 32. Then we have to consider order of operations. Order of operations says that we're going to multiply these two first and then add the 32. So we're going to do 1.8 times 92 and then add 32. We get 197.6. Okay, pause the video, work through the next two problems. All right, so now that we want to get Celsius, we're going to use the equation degrees Celsius equals our degrees Fahrenheit minus 32 divided by 1.8. So we are going to insert this into the Fahrenheit box here. So that becomes degrees Celsius equals 22 minus 32, and that's in parentheses, divided by 1.8. We're going to do the parentheses first. 22 minus 32 equals minus 10. Divided by 1.8. We get minus 5.55 degrees Celsius. Okay, next one, 98.6 degrees Fahrenheit. And we want to convert that to Celsius. So degrees Celsius equals 98.6 minus 32 divided by 1.8. And we end up with 37. So this one is significant because 98.6 degrees is our average healthy human body temperature, and 37C is our typical incubator temperature in the clinical setting. Sometimes 35 is what we go with. We go a little bit colder than body temperature, but if we're trying to culture human pathogens in the laboratory, we're going to culture them at body temperature because they tend to grow best. If they're colonizing us, and they're able to cause disease in us, then they probably like growing in that temperature. So we mimic that temperature in the incubators in the lab.